Hi students, welcome to Vedantu JEE English. I'm Diksha, your chemistry master teacher. And students, today we are going to talk about aldehyde ketones and carboxylic acids. We are going to do some questions here, previous year questions, right? Some of the expected questions for your JEE mains and advanced, and also we are going to cover carboxylic acid today. Okay, so most of it will be 50% questions and 50% theory, right? So the questions, the theory that we have done in the last lecture, that is yesterday, I have completed aldehydes and ketones, right? We are going to do the questions of that as well. Okay guys, so everybody, are you ready for the session? If yes, then green hearts in the chat box. Everybody, are you ready? Is the energy, the Josh, the energy high in the chat box? Let us see, let us see, let us see. Now, so many of you were asking that, ma'am, is this chapter important or not? So this is actually one of the most important chapter from organic chemistry, right? It has a highest weightage, right? If you talk about hydrocarbons, alcohol, phenols, right? This among those chapter has the highest weightage, right? And so many questions that you will see are being repeated from the other chapters as well. And so many concepts and the naming reactions are very new to you. Mostly, in even the distinguished tests are also maximum in this case, right? Okay, I think the Josh is not high. I think you guys are not ready for the class. Is it? I think you guys are not ready for the class. You guys are not interested in the class, is it? Let me see. Let us see what is going to happen. Okay. Now I have texted the students that I am live. Now let us see how many of you are actually interested in studying and how many of you just want to create this dream in your head that I want to get into this IIT, this NIT, this is what I want to achieve, but you don't want to work on that, right? So to work on something, you have to be present in the class, you have to listen to the teacher, you have to also conclude the questions, right? What the teacher is asking you have to conclude it yourself also, right? Okay. I can't see your energy in the chat box. It feels like I don't want to teach you only. Why? Because your energy is so low, right? How can a teacher stand here for 3 hours when the students are so dull, right? Let me see. Let me see. I'll only start the lecture if I feel that you guys are interested, right? There's the 1-2 lectures, so I can assume that you guys don't know me that much well. You're like, okay, some new teacher is teaching us now, right? So let us make bond with the teacher, right? But now you already know that who is Diksha ma'am, how Diksha ma'am teaches, right? But now is the time for that bond, for that interaction that I want to have with you guys. Okay? Yes, Radhika, Sai, I would say Sai, Radhika, Nani Uma, then Yog with Sonali, right? Setija. Only these students are interested. Huh? You guys were asking, ma'am, please increase the number of lectures. Right now, I have increased the number of lectures. Even now, the students are not interested. Huh? What is this? What is this, bacho? What is this? Don't be so confused. Don't be so non-interested. Right? Otherwise, so I'll also go non-interested in you. Okay, if I get energy, if my energy is low, automatically everything will be drained. Right? Okay, chalo. Now, let me start the session. Though I'm not very satisfied with the energies, with the kind of chats that you're giving in the chat box, right? I'm not very happy with that, but still I'll teach. Right? If you want me to teach with a beautiful smile, then I have to see the chat box very interactive and chat box very enthusiastic, right? So now let us see, firstly let us recap what we have studied in the previous lecture with the help of some questions, right? So the first one is find the product of the reactants, right? So you need to find the product of the reaction. So from this we are going to recap what we have studied in the previous lecture. So now it is showing that it has a double bond with CH3 and you are using KMNO4 in basic, medium and heat. Right, that clearly shows that we are going to do oxidation. We are going to do oxidation with heat. Now tell me, is this a case of oxidative? Say I told you one thing, that there is reductive and there is oxidative ozonolysis, right? So when you talk about, when you only have acidic KMNO4 or you have heat and KMNO4, in that case the answer will be same as oxidative ozonolysis, right? But if here they have not written that this is heat, then the answer would be same as a reductive ozonolysis, right? So here the answer is going to be same as oxidative ozonolysis. Oxidative ozonolysis, the answer is going to be same. So if I say that, if instead of writing KMNO4OH negative, that means KMNO4 in alkaline medium with heat, instead of this, if they have written the reagent, if they have written the reagent as, O3 H2O2, the answer would be same, because this is called oxidative ozonolysis, right? Okay. Now, let us see how to answer this thing. So, you have this thing, you have this square, right? Then you have this square, then you have one double bond here and one CH3 here. That is your question, right? Now, we want to know what kind of answer it will give us, right? We want to know that. I told you that whenever you have a double bond, you just need to break the double bond. Yes. Welcome, welcome Anandu. Welcome. Yes. Now you just need to break the double bond here, right? Break the double bond. And what you need to do next? What you need to do this? Now break this double bond and attach double bond oxygen there, right? So write it as it is. Write it as it is. Right, write it as it is. This is the double bond. And now what we are going to do, we are going to break this double bond and attach double bond O here, right? And attach double bond O here. And attach double bond O here, right? Now, this is the answer for reductive ozonolysis, right? But I know I also have one hydrogen over here. Here I don't have any hydrogen. So what I'll do, for the further oxidation, this hydrogen will be replaced by OH. So answer will be this is CH3, this is double bond O, this is double bond O, and this is H. No, this is OH, right? Because H is converted to OH. So that is going to be your final answer for alkaline KMNO4 in the presence of heat. Okay, when you are providing it heat. Right, and that is the answer for oxidative ozonolysis also, right? So that becomes your first answer, that is this one, right? Okay, next is, when you have, this is JEE Mains 2015 question, which compound would give 5-keto-2-methyl-hexanal on ozonolysis, right? What they are saying, which compound will give you 5-keto-2-methyl-hexanal on ozonolysis, right? On ozonolysis, you need 5-keto-2-methyl-hexanal, right? Hexanal means you need to have six carbons, right? And hexanal means that aldehyde should be on the last position, obviously. So it will be here, right? Then you have 5-keto. It is 1, 2, 3, 4, 5. That means, wait a minute. These are 5 carbons, no? So we need to have 6 carbons. So there will be 1 carbon over here also. So I'm drawing it like this. 1, 2, 3, 4, 5, 6. On the 5th position, you need to have this ketone. 5-keto-2-methyl. That means here you should have methyl. This is the product that they are asking you. They are asking you what should be the reactant, right? What will be the reactant? Which compound will give this on ozonolysis, right? If you talk about, we need to have that compound, right? So, just break the bond everywhere. If you break this bond here, the answer will be double bond O, right? Okay, that means double bond O, CH3, double bond O, CH3, right? And here it will be CH3. No, the answer will not be this one, right? Because we are not able to form that compound. Again, here it will be double bond O. Now the answer will be CH3, C double bond. Then again, what you will have, CH3, C double bond, then you have a carbon which should have a methyl group. No, that is also not the correct answer. You break one double bond over here. You break one double bond over here. Now let us see. This is CH3, C double bond, CH3, C double bond. If you want to write it, you can write it like this. CH2, CH2, CH, that's it. Okay. Now CH3, C double bond, then you have CH2, then you again have CH2, then you again, basically if you want to write 1, 2, 3, 4 here, so if this is my first, this is 1, 2, 3, 4, 5, 6. And here I am making the aldehyde as this one. Here both of them will be ketones, so this is not possible only, right? I want one aldehyde. So if this is my double bond, this is my double bond. Now can I say that is the correct answer? If I just erase this double bond here, now tell me, is that the correct answer? That is your aldehyde group, right? One position. Second position you have methyl group, yes. Third position you have CH2, yes. Fourth position you have CH2, yes. Fifth position you have ketonic group, yes. Sixth position you have CH3, yes. So is this the right answer? Definitely yes, this will become the right answer. That means after breaking this bond, you will be able to make this on ozonolysis, right? Okay guys, D is the correct answer. So D becomes the correct answer, right? Very good, very good, very good. I'm so happy to know that you guys are answering it. Next is, you have this compound. It is in acidic hydration, right? That in the presence of Hg2 positive ions, how a alkyne is converted into aldehyde or ketone. This reaction we did yesterday, right? So let us do it now. So it is CH3, CH2, C triple bond CH. CH3, CH2, wait a minute. So it will be CH3, CH2, C triple bond CH, right? That is your reactant side. Now what we need to do, everybody? Tell me, now what we need to do? There is a one thing involved, that is tautomerism, right? There is a one thing involved, that is tautomerism, and everything else is same. First thing is, this occurs by carbocation mechanism that you need to understand, right? So what I mean by that when you are adding H positive and OH negative in this case, because this is a case of acidic hydration, so you are going to break this bond. Either electrons will jump here or electrons will jump here. You can have two kind of situations, that will be CH3, CH2, C double bond CH, right? If the electrons will jump here, it will be negative here and positive here. Now the second situation is, if the electrons are jumping on the opposite side. If the electrons are jumping on this carbon, so it will be a negative here, it will be a positive here, right? Now, firstly, this occurs by carbocation mechanism. That means this negative will already have a positive, already have a hydrogen here. So I'm just going to erase this here, and this will be H2 and this will have a hydrogen here. Now these are the two carbocation that we have. Can you tell me which is more stable carbocation? Which is more stable? To this carbocation, this alkyl group is still far away. But to this carbocation, this alkyl group, this electron donating group is very near, right? So when a positive thing, when a positive carbocation has electron donating group, right? When you are very poor, someone is giving you money, you feel very happy about it. You will not be sad that I have so much money, I don't want more money. You'll be happy that, okay, give me more money, right? So now here they are giving it more money. So that is why carbocation is more stable. That is the reason we are going to skip this thing here and we are going to choose this thing here, and hence we will choose this thing. And after that, OH will be attached here, OH will be attached here, and then the answer will be, this is CH3, CH2, this is COH, and this is double bond CH2. Now, what is this? This is enol form. Here you have ene, that is alkene, and this is alcohol, that is ol. So this is your enol form, right? Now we are going to do tautomerism here, right? Now we are going to do tautomerism. Tautomerism. With the tautomerism, a very simple thing. With the tautomerism, a very simple thing we are going to do here. That is that is, wait a minute, that is, we will convert this, basically this is 1, this is 2, this is 3, right? Write it as it is, this is CH3, CH2, this is C double bond CH2 and this is OH, right? So now this hydrogen is going to shift on this carbon, so it will be CH3 and this double bond is going to shift here, right? So that will be, this double bond is going to shift here, wait a minute, double bond is going to shift here, so it will be a single bond and here you will have a double bond, so that becomes a keto form. So this is a ketone is formed, right? Okay, that is called tautomerism. Understood this whole process? Guys, are you able to understand this whole process or not? Are you able to understand this whole process or not? Everybody. What we did here, we added water, right? Acidic hydration. After that, we thought that which should be the correct answer, which should be carbocation that we should choose. So definitely this has inductive effect. It is more stable. That is why I have choose this carbocation here. Mostly you will choose inner carbocation only. Terminal carbocation is not chosen. Right? That is the thing that I am telling you, that inner, here only you will see positive. When you have a terminal alkyne, this thing will be chosen, right? That is in the inner part, that carbon will be chosen, right? Then you do what you do tautomerism and you will get your answer, right? Okay, yes, everybody, thank you so much, electronics and hardware, right? Now my birthday is gone, it's like 1 month, you just wished me, how many days? Yes, you have wished me 1 month late, okay? So this is CH3, C double bond O, CH2, CH2. Okay, this is the thing that you will get. Next is identify the compound Y in the following sequence of reactions. Now you have to identify the compound here. Firstly, when you have Cl and Cl, you are adding KOH here. Then this vicinal dihalides will be converted to vicinal diols, right? That is OH and OH. After that, one OH negative will be taken because one carbon cannot handle two OH groups. So one OH negative will be eliminated and one hydrogen from here will be eliminated because it will be something like this. It will be something like this. Hydrogen will be eliminated, bond will shift here, right? So that is why hydrogen is eliminated in the form of water, right? OH from here, H from here, and then you will get CH3, CH, and this basically will be CH, and this here will be your double bond O. You will get CH3, CHO, that is C will be your correct answer, right? Very good. C is going to be the correct answer. Very, very good, right? Now, next question is 2014 question. The most suitable reagent for the conversion, right? Now they are asking the most stable reagent for the conversion, this, right? Now they have, what they have done, they have converted 1 degree alcohol to aldehyde. 1 degree alcohol to aldehyde, right? That means oxidation definitely is happening here, right? Definitely, very good. Oxidation definitely is happening here, right? And we need a mild oxidizing agent. Now, which of the following is a mild oxidizing agent? Definitely not KMNO4, not K2Cr2O7, not CrO3. Now, PCC is your mild oxidizing agent. So, D is going to be the correct answer. Very good, very good, very good. Right, D is going to be the correct answer. Next is, okay, next is this one. Now, this is also interesting. 2020 latest question it is. So, let us try to answer this. Very, very simple question it is, right? So, what they try to ask you maximum questions. So, you will see a lot of questions which has matched the following, right? Now, after this lecture, after the theory part, we are going to take up a lot of questions, right? A lot of questions, right? Around 20-25 questions we will take. From that, you will be able to realize that how many questions they ask from match the following, right? So, this is correct match between item A and item B for the preparation of benzaldehyde. Now, what is benzaldehyde? This is called benzaldehyde. This is benzene. On the benzene, when you have CHO group, that is called benzaldehyde, right? Now, for this benzaldehyde, if you talk, basically two things are given to you, right? So, here, if you talk about benzene, right? If you talk about benzene here, very simple. if you want to convert benzene to benzaldehyde, the reaction is called Gattermann-Koch reaction. Do you remember that reaction? When we used to convert this benzene to CH, we just applied that, we just attached the CHO group here. And that is done by Gattermann-Koch reaction, and the reagents are very good. The reagents are CO, HCl, AlCl3. That are the reagents. So benzene will be connected to R. One is R, one is R, one is R. Right? One is R over here and here. That means A and B cannot be the answer. Definitely they cannot be the answer. Next is benzonitrile. Now what is benzonitrile? Benzonitrile means on the benzene you have C triple bond N. When you want to convert C triple bond N to CHO, you want to convert C triple bond N to CHO. Do you remember what was the reagent that we were using? What was the name of the reaction? Anybody in the chat box? What was the name of the reaction? Okay, I'll tell you the reagent. Reagent is HCl, SnCl2 and hydrolysis. Now, can you remember what was the name of that reaction? Everybody, they can also ask you the name of the reaction here directly. That you want to convert benzonitrile to benzaldehyde. What is the name of that reaction? That reaction is called Stephen's reaction. Okay, Stephen's reaction. So that is, for second we have P. For second we want to have P. So definitely D is also not the correct answer. Answer C is the correct answer. Right, but still we will see that what is benzoyl chloride. If you talk about benzoyl chloride, what is benzoyl chloride? Very good. What is benzoyl chloride? This is benzoyl chloride. When you have C double bond O, Cl, right? Instead of, we just need to convert this Cl to H. Just need to convert this Cl to H. Now, this is done by Rosenmund reduction. Very good, Rosenmund reduction. And that reaction is H2 PDBSO4. You have used Lindlar's catalyst, that is, you have used a poison, like a sulfur poison you have used, that is BSO4. Sulfur or quinoline, these are the poisons that you can use, right? Okay, that is called Rosenmund reaction. So C will become the correct answer. Okay, so next is C is the correct answer. Wait a minute, right? So next is, yes, so this is Gattermann-Koch, this is Stephen's reduction, and this is Rosenmund reduction, right? Okay guys, everybody in the chat box, shall we start with carboxylic acids, right? It's not like, ma'am, only these many questions for aldehyde and ketones. Don't worry, right? So many questions I have for you for aldehydes and ketones, right? That was just a recap so that you can get into the zone of understanding carboxylic acid, right? That was just a trailer, right? The movie is still, we are going to watch the movie, right? So, okay, everybody, shall we start it? Shall we start it? The carboxylic acid, right? So, firstly, we are going to see the structure. Then we are going to see the preparations, physical and chemical properties. These are the 4 things that we are going to see in today's lecture. And after that, we are going to see some previous year questions, very, very important and interesting questions, right? Okay. Now, very good, Nani, very good. Now, this, it says that what is the structure of carboxylic acid? We know that carboxylic acid means this is COH, right? And this is your R. Now tell me, what is the hybridization here? We know that this is sigma, it is sigma, it has 3 sigma. That definitely means it is sp2 hybridized. That means it is trigonal. It is trigonal planar geometry, right? This is trigonal planar geometry. Now, if I am saying it is a trigonal planar geometry, it means same as we have done in aldehyde. This is the trigonal planar geometry which has 120 degree. It is in one plane, right? This is one plane, right? If I talk about this plane, this is in one plane. This is in one plane, right? So that is called trigonal planar geometry. Now, in this, what we will have a OH here. Suppose this is OH. Suppose this is R, and this is your C double bond O, right? This is your C double bond O, this is R, and this is OH, right? So that becomes your total structure. So now let us see, in carboxylic acid, the bonds of the carboxyl carbon lined one plane, right, are separated by 120 degree angles to each other. Next is the carboxylic carbon is less electrophilic. They are saying that why this is less electrophilic? Can you tell me? Because of the resonance that is involved here. Now we know that this carbonyl carbon has electronegativity difference. Oxygen is more electronegative and carbon is more electropositive. That we all know. We have done this in aldehyde also, in ketones also we have done this. But you know, in this case, it is even lower than the aldehydes and ketones. What is the reason behind that? The reason is the resonating structures, the resonance structures here. This is lone pair, single bond, double bond. And when you have a condition like lone pair, single bond, double bond, that accounts for the resonance, right? That means there will be resonance here, right? So that is actually a condition of resonance. So this lone pairs will shift here, and this double bond, this pi electrons will shift on this carbon. It will have a negative charge here, and this will have a positive charge here, right? So that will happen. Or you can just simply say they have drawn in 2 steps. I have told you to draw it in 1 step. Totally your choice, right? They have firstly distributed the pi electrons to this oxygen. Then they have distributed this lone pair to this carbon. Basically, these 2 structures are formed here, right? If you have C double bond O, this is O, and this is H, and this is R. So what is going to happen? These lone pairs are going to shift here. The pi bond is going to shift here. That is why what you will have here, you will have, this is R, this is C, this becomes O negative because pi electrons have shifted there. This is double bond, this is O, and this is H. Now, because this oxygen has distributed its lone pair, that is why it is bonding. It is forming 3 bonds here. Whenever oxygen is forming 3 bonds, we apply 1 positive there, right? Oxygen usually, for example, you are like, I can get 700 marks or I can get not in this. You can get, for example, you are saying I can get 99 percentile, right? But you, no. Let us assume you are thinking that I'll get 95 percentile, but you got 99. Now that is more than your expectations, right? So now here also what will happen? Oxygen always forms 2 bonds, but if it is forming 3 bonds, it will have a positive charge. Nitrogen always in the neutral state, it will form 3 bonds, but if nitrogen is forming 4 bonds, it will have a positive charge. Right, so similarly, it will have a positive charge here, right? So now this is also electrically neutral, this is also electrically neutral because the charges are balancing each other. And this exists as a resonating structure. Why we are saying that? Because the electrons are revolving here, right? Electrons are delocalizing here, right? So this carbon who was supposed to be electron deficient is not that much electron deficient because the electrons are moving in this line, right? The electrons are moving here and there. So that is why this electron was supposed to be electron deficient, but it is not that much electron deficient. This is what they are saying is, it is less electrophilic than the carbonyl carbon because of the possible resonating structures, right? Okay, everybody. Now let us do the preparations of carboxylic acids, right? Very, very important. 2 mechanisms are very important here. One is Gabriel phthalimide, other is Hoffman bromamide, right? And HVZ reaction is also very, these 3 reactions are very important, right? Gabriel phthalimide, sorry, I talked about that here, right? Gabriel phthalimide is in amines, but yes, in this we have Hoffman bromamide, we have HVZ, very, very important, right? So firstly, let us talk about from primary alcohols how to form carboxylic acids. So definitely by using oxidizing agents, right? If you talk about you have alcohol, then it is with mild oxidizing agent, it will be converted to aldehyde or ketone. But with strong oxidizing agent, it will be converted to carboxylic acids. And we know that if that alcohol is primary, only then that is possible, because primary alcohol on mild oxidation is converted to aldehyde. Then after strong oxidation, it is converted to carboxylic acid. This we have done in yesterday's class also. This we have done in alcohol, phenols, ethers also, right? This thing is repeated only. So this is what they are saying. Primary alcohols are oxidized to carboxylic acid with common oxidizing agents which are strong. right? All these are examples of strong oxidizing agents. You talk about KMNO4 in neutral or acidic medium, alkaline K2Cr2O7. You talk about CrO3 in acidic medium, that is called Jones reagent. These three are strong oxidizing agents. I'll just write it here. You will need strong oxidizing agents here, not mild oxidizing agents. PCC, PDC will not work here, right? Okay. Yes. 2 degree to ketone. Yes, 2 degree will not get oxidized to a carboxylic acid any day, right? That will be, even with strong oxidizing agent, it will be oxidized to ketones, right? So now here are a few examples that we have. 1 degree alcohols, right? Alkaline KMNO4 and hydrolysis, this will be converted to the same number of carbons, right? This has R plus C, this is also R plus C. So that is this alkyl chain plus this CH2OH is converted to COH. Here also, here what you have, this is also a primary alcohol, that is why this particular group is converted to COOH in the presence of Jones reagent, that is CrO3 in presence of acetone or acetic acid, or you can say H2SO4, right? Then the second part is, this was the first, the second is from aldehydes. So if you want to form carboxylic acids from aldehydes, what you are going to do, right? So aldehydes, have we done this before? Have we done this before? Have we done the oxidizing agents? Have we done these mild oxidizing agents, right, before or not? Tollens reagent, right? Because see, we know that from OH to aldehyde, you need mild. From aldehyde to COH also, you need mild. But from OH to COH, you need strong. You need strong acetic acid. You need strong oxidizing agent, right? So that is why from aldehyde to ketones, right? From aldehyde to carboxylic acid, we need mild oxidizing agents like Tollens reagent, like Felling's reagent, and these two reagents, they are not going to convert ketones to carboxylic acids. They are only going to convert aldehydes to carboxylic acids, right? So first is your Tollens reagent. Carboxylic acid also prepared from aldehydes by the use of mild oxidizing agent, that is Tollens and Felling solution. Tollens test is ammonical nitrate solution, right? So that is ammonical silver nitrate solution, right? Here your Ag positive is converted to a silver mirror, right? Definitely here reduction is happening and this RCHO group is converted to acid, right? Where oxidation is happening. Where oxidation is happening, right? Understood this or not? Is that clear to everybody or not? Right? Okay. Now, next is Felling solution test. Right? Now, Felling solution test means you will have Felling A and Felling B solution. You will have copper sulfate, that is the Felling A solution. You will have sodium potassium tartrate, that is your Felling B solution. When you will mix these two together, it will form a deep blue color. And when you add any aldehyde into it, then it will convert it into red-brown PPTs, right? Reddish-brown precipitates will be formed. This is reddish-brown precipitate. Reddish, or you can say brick red precipitates. I would say brick red, right? Brick red precipitates is formed. This then we can say that definitely you have there is some aldehyde group that is present here. Felling test is given by only aliphatic, right? But Tollens is given by both aliphatic and aromatic, right? Next is from Alkylbenzene. Now this is a very, very important reaction. Why? Because Alkylbenzene means on this benzene ring you have a alkyl chain, right? On this benzene ring you have a alkyl chain. Now I am going to tell you a very interesting reaction that is used and asked to you in chain reactions as well, right? So here the reagent that we are going to use is going to convert this full alkyl chain to COOH. Doesn't matter, in that alkyl chain it has 1 carbon, 2 carbon, 100 carbon, 1000 carbon, doesn't matter, right? It's just that it will convert the full alkyl chain to COOH, right? That is why this reaction is very important. So aromatic carboxylic acid can be prepared by vigorous oxidation of alkyl benzene with chromic acid or acidic alkaline potassium permanganate, right? That is a very vigorous reaction, very strong oxidation. The entire side chain is oxidized, right? Doesn't matter it has thousand, millions, it doesn't matter how many carbon atoms it will have. The whole chain will be converted to COOH, right? Interesting, no? So whether you have here, whether you have CH3, that will be converted to COH. Whether you have CH2CH3, that will also be converted to benzoic acid only, right? Doesn't matter what you have. Next is, now irrespective of the length, tertiary, now this is very important, very important. Tertiary alkyl group is not affected. That means on this benzene ring, if you have a tertiary alkyl group like this will not be affected. Rest of any alkyl chain you have, that will be affected. But if here you have any tertiary group, that will not be affected by this reaction. Okay? Yes, everybody? Yes, I got to know that. That's a very, very disappointing thing. Very, very disappointing thing. Right? So, what to do here? Right? That's actually, they should be ashamed that they are so less focused that they don't know how they are playing with the life of students. The students are actually preparing for this for years, right? How they are actually passing the wrong information, right? So yes, chalo, let's focus on this thing here, right? So now this is your CH3, this is CH2, CH2, CH3. Both are converted into benzoic acid. This is also COH, this is also COH. That is why this reaction is very interesting, right? That is why this reaction is very interesting, right? Okay, guys. Now, next is from nitriles and amides. Now, if you have nitriles, that means you have C triple bond N or you have C double bond OH, C double bond O NH2. Now, how to convert these two things to COOH? That is the task. So, now let us see the reaction. Nitriles are hydrolyzed to amides in presence of, very important reaction it is, in presence of H positive or OH negative as catalyst. Then that amide then hydrolyzed to acids in the presence of this same as catalyst. Let us see this here. Now, for example, you have any nitrile, right? You will do the, in the presence of H positive and OH negative, right, or OH negative, you will do the hydration here. Now, this triple bond that you had will be converted to, here what you will have, two bonds will break, here you will have two H hydrogens and you will have one oxygen here, right? What is going to happen? You will have C triple bond N, two bonds it will break, right? Or you can just see one thing, it has H, two hydrogens and one oxygen. Two bonds will break, one oxygen will be added here and two hydrogens will be added here. That is how water is added to nitrile, right? And it is converted to amide, right? Okay. Now, next thing is, once it is converted to amide, then you again do the same process. Then this NH2 will be replaced by OH here and you will convert it into carboxylic acid, right? Okay, guys. Now, here you have simple amide, then this NH2 will be converted to OH and hence you will have your acid here. So basically, how to convert nitriles and amides? You just need to use the presence of H positive or OH negative as the catalyst. You need to do the hydrolysis here, right? Okay, guys. Now, next is, this to we have done. Next is this reaction. This reaction is frequently asked reaction, right? You will see this in your previous year questions as well, right? Yes, this simple, because in exam, what do you think? Even the easiest reactions you tend to forget. Why? Because you are not able to retrieve everything that you have studied, right? If you have not practiced well. That is why you will see, ma'am, this is such an easy question to be asked, right? But yes, these are asked, right? These are asked. No, it's not like directly they will be asked. In match the following or something like that, they are asked, right? Okay, so don't just ignore the easy questions as well. You never know, that can also be asked to you, right? So this is CONH2. This is converted to OH here on hydrolysis, right, in presence of acid or a base. Next is from Grignard's reagent, how to do, right? So you have Grignard reagent and this is carbon dioxide. Very, very interesting reaction. I'm going to do this myself only. You have C double bond O and this is RMgX, right? Same thing that we did yesterday. We know that this is an organometallic compound, Grignard reagents. Metal are more electropositive as compared to carbon. That is why it will be like this. Now, if you compare carbon and oxygen, definitely oxygen is more electronegative and carbon is more electropositive. That is the reason this negative part is going to attack here. Electrons are going to jump here. And what you will have here, and what you're going to have here, you are going to have this thing that this is C double bond O and this is O negative because electrons are jumping there. So this is R here that is attached to this carbon and here you have MgX, right? That is your positive MgX, right? Now this is further converted. Now after hydrolysis, this is further converted to this OMgX is converted to OH. So it will be C double bond O, this is OH and this is your R and that becomes your carboxylic acid, right? And that becomes your carboxylic acid that we wanted to from Grignard reagent and a reaction with carbon dioxide, okay? Reaction of very, very good evening, Rohit, very, very good evening. Okay, now is that clear to everybody or not? Tell me, right? Is this thing clear to how we are able to form this thing, right? Is that clear? Now, Grignard reagent react with carbon dioxide, that is dry ice that you must have seen in concerts or maybe in weddings. You must have seen that dry ice, that dhua, that white kind of dhua, right? To form salts of carboxylic acids. Salt give corresponding carboxylic acid after acidification with mineral acid. Now, step-up reaction as number increases. Now, why this is called step-up reaction? Because number of carbon atoms are increasing. Here you had RMgX and here you had RCOH, right? That means one carbon more you will have in the final answer, right? Okay, guys. Next is, if you're not going to reply, I'm not going to teach and I'm very, very serious on that, right? I'm very, very serious on that. I'm not even kidding, guys. I'm not even kidding, right? That's not, if I am not a robot here sitting, like standing here. Trust me, I'm not an artificially intelligence extracted human being. No, I am a real person and a real person obviously need your response, right? Even Siri will not respond if you don't respond to the Siri, right? I am the actual human being, guys. I know I'm in front of camera, but I am actual human being, okay? I'm just like you, right? So even I need some response from you guys. If you're not responding, I won't be able to teach here, right? That's not how I interact. That's not my nature, right? And I can't go against my nature, right? That is my teaching style. I want to know if my students are able to understand this or not. Otherwise, teaching in the camera for me is not like teaching the walls. For me, you guys are real, right? You guys are not robots, right? So I want to know whether you're able to understand this or not, right? Okay. Yes, definitely that is an organometallic compound. Organometallic compounds is which carbon is connected to a metal, right? Those are the organometallic compounds, right? Like Gilman's reagent, right? There are so many other there is proper study of organometallic compounds, but that is not in your syllabus, right? That is in MSc level you will see the study of organometallic compounds, but not even in BSc, right? It is in MSc, right? Okay, okay, guys. Even now there is no reply, huh? That means I am stupid standing here, is it? Chalo, okay, don't worry, I am going to end this lecture now only, right? I don't ask anything from you guys. If I ask is your response. If you can't give me that, I'm not going to teach you. As simple as that, okay? As simple as that. Voluntarily, I thought that I want to teach these kids. Why? Because I was like, okay, I don't want you to spoil your, JEE paper in the end, right? So that was our responsibility. That was Vedantu's responsibility to cover your syllabus on time, right? That's why I'm here, and still you guys are not responding. So that's very, very, very disappointing. Very disappointing. You guys are not responding. Even I'll be standing here. Even I will not respond. I'll be standing here just like that. Okay, I'll sing for myself. You don't know how stubborn I am, right? This is actually insult that you guys are doing. Nothing more than that. Chalo. Then guys, I think that's it. Your aldehyde ketones is completed, right, from my side, because today's lecture was supposed to be aldehyde ketones and carboxylic acid. I'll send you all the PPT. I'll send you all the notes. You can go through that, right? And that's it. Okay? Is that fine? Is that okay with you guys? Chalo. Okay then. I'll be ending this class now. Now I will not teach you aldehyde ketones, right? I'll see if I have the mood to teach you other things or not, right? Because you are thinking about your mood. You are thinking about that, yes, ma'am, if I want to respond or not, even I will behave the same way, right? This is not how you should treat a teacher, right? Okay then. Bye-bye. Okay. I'm also good at heart, so it's very difficult for me to stay angry with you guys for a long time, right? So guys, yes. So kindly respond in the chat box, otherwise it will be very, very difficult for me to teach, right? Because I am seriously not that teacher who will be like, hi students, today let us start carboxylic acids. This is carboxylic acid. This is preparation. This is properties. I don't care whether you are able to understand that or not. I will not even see the chat. Okay, bye. Do you want me to teach like that? Like a dead body in the camera, right? So if you don't want me to behave like a dead body, then you should not behave like that. Okay? Chal. Now, let us see preparation of carboxylic acid from acyl halides and anhydrides, right? So acyl halides means when you have RC double bond OCl, or you can say that acyl halide means X here. Anhydride means you have R C double bond O C double bond O R. Now, can you recall some this kind of reaction where we used to do esterification? Do you remember that kind of reaction? We used to have COOH and you used to have alcohol and you used to make ester from that, right? if you remember that. Now the hydrolysis of ester used to give you carboxylic acid. So this is something like that only. Right here, what we are going to do, we are just going to eliminate this thing here, right? This thing, this bond will break, this bond will break. What will happen when this bond will break, right? Here you will have the hydrolysis, right? So basically what you're going to do, acid chlorides when hydrolyzed with water, when you hydrolyze it with water, so what is going to happen? You will have H positive, you will have OH negative. This OH negative is going to attach to this carbon, and here you will have the formation of RC double bond O, OH plus. This H positive is going to attach with this X, so it will be HX. HX will be eliminated here. If you talk about anhydride, again, anhydrides are hydrolyzed to corresponding acids with water. You will have H positive, you will have OH negative. This is a way to tell you how to remember these questions, right? So this is a negative part, right? And this is your, this bond will break, then what will happen? This will be RC double bond O, and OH will be attached here. This will be carboxylic acid plus this, for example, I am saying this is R dash. Okay, this is just an example that I am saying this is your R dash, right? If this I am assuming is R dash, right? If I am assuming this to be R dash, so what we can say, this is R dash C double bond O, and this is double bond O, and this is O, and one hydrogen will be attached here. So that means two acid molecule will be formed from the anhydride, one molecule from the acid halide, right? So this was the reaction. Here they have given it in a very sophisticated manner, right? But we have written it in our own language, that you will just need to break this bond, CX bond or CU bond here, right? And attach OH over there, right? And you will get your corresponding acid, right? Corresponding carboxylic acid. Next is, now they are giving you two examples. They are saying that you have C6H5CO twice O, right? That means what you have, they are saying that you have, in this case, that means they are saying you have benzene, this is C double bond O, this is O, this is C double bond O, and this is benzene. This is what they are saying that you have. And when you hydrolyze this thing, one bond will break and you will get benzene, C double bond O, attach OH here, plus here you will get benzene, C double bond O, O, and here you attach H positive, so that will be two benzoic acids will be formed in this case, right? Okay, two benzoic acids will be formed in this case, right? Okay, yes. Now let us see. Now let us see the next thing. The next thing here, you have benzene here. This is C double bond O. This is O. This is C double bond O. This is CH3. You are hydrolyzing it, and what will be formed? Break the bond, right? Either you break this bond or you break this bond, doesn't matter. You are going to have acid. You are going to have carboxylic acid only, right? So this is benzene, C double bond O. Attach OH over here, right? Plus this is CH3, so that is CH3, or you can just write CH3. This is a C double bond O, and this is OH, right? That is another acid that is formed. One is acetic acid, other is benzoic acid is formed from this benzoic ethanoic anhydride. Okay, got it? Everybody got it or not? Now from ester, same thing we are going to do. Same thing we are going to do here, that you have RC double bond O, OR dash, right? Break this bond and attach H positive and OH negative correspondingly. So here what you will do, this is RC double bond O, right? Just attach negative here, right? Attach OH here. Plus this is RO, so just write R dash O, attach H positive here, and because this carbon and oxygen, carbon is less electropositive, no? So that is why it will have a positive charge. Positive, negative will be attached, that is OH is attached. Here to this negative, positive attached, that is H is attached. So this is one carboxylic acid, and other alcohol is formed from hydrolysis of ester, right? So that is opposite of esterification reaction. Acidic hydrolysis of ester gives directly carboxylic acid. Very important point, that if you use acidic hydrolysis, then you will get directly carboxylic acids will be formed. But if you use basic hydrolysis, then the salt of carboxylic acid will be formed, right? Which on salt of carboxylic acid means, if you have basic hydrolysis here, this is alkaline for example, you are using alkaline, it has more amount of base here, hydrolysis, you are adding base here, then you will have the formation of, for example, the base is NaOH, right? Then you will have the formation of this salt if you have basic. But ma'am, for acidic, why salt is not formed? Because in acidic, you have more concentration of H positive ions. So automatically this Na will be converted to H. That is why directly you will have carboxylic acids. But with basic hydrolysis, you will have to acidify it. Then you will get the carboxylic acid. Right? Okay guys, is that clear? Solve around 20 years, right? Yeah, 20-25 years, so you must solve, right? That is a must thing, right? Okay, next is from esters. Now from esters, again we have done this, break this bond, this will be CO, basically this will be benzene, this will be CO, OH will be attached here, and here H will be attached. So you will have COOH and this will be C2H5OH, right? So these two things will be formed from hydrolysis of ester, right? Formed from hydrolysis of ester. Yes, BSO4, what a name, right? Ma'am, if possible, please do it. Like applied it, did you submit it? I don't remember what you were saying. How many years PYQ should I solve for mains? Yes, BSO for barium sulfate, I have already told you, right, that solve as many previous year questions, at least 20 year questions, so you must solve, right? 10 is so 2-3 times, last 10 year question to solve it 2-3 times, right? If you talk about last 20 year question, go through that once, and last 30 years, if you can do last 30 years, that would be great, right? That would be really great, right? Now here also same thing, yeah, same thing, right? Here they are saying that basic hydrolysis you have. So when you have basic hydrolysis, and the mechanism is not important in these cases, right? I'll tell you where mechanism is important, right? This is where students do mistake. They just cram all the mechanisms given, right? You don't need to do that, right? That's a smart work, right? That is why teachers are here for you. Here mechanism is not necessary. Here the reaction is also not that much important, right? Just need to remember that whenever you do hydrolysis of acyl halide, or you do hydrolysis of anhydride or esters, then you need to break this bond here, this bond, whether it's X, whether it's OH, whether it's OR, whether it's any anhydride, you just need to break this bond here, right? So break this bond here, you will have COOH here. Now this is basic hydrolysis, so instead of OH you will firstly have ONe here, right? That means you will have carboxylic salt, and here you will have alcohol, that is OH. Then you will further acidify it and it will be converted to the acid instead of acid salt, right? Okay, yes. I live in a different state in JEE from 12, the bearing state as the state I live in is okay. So it depends that where you have done your dummy school, right? So it depends on that, right? So many students do this thing, right? So where you have filled your dummy school, right? There you can apply for your, because you have done your 12th from there, no? So you will get the quota, right? Which is given to those students who have done 12th from there, right? So you have already done your dummy schooling in Delhi, so apply from there, right? Okay, now next is physical properties of carboxylic acid. So now let us see the physical properties of carboxylic acids. Lower fatty acids, right? Now lower fatty acids means less number of carbon, which have up to C10 are colorless liquids, like they are colorless liquids, but higher ones are colorless waxy solids, right? Higher ones are colorless waxy solids. If we talk about the example of vinegar, right, that is a colorless liquid, right? Now Lower members are highly soluble in water. If you talk about acetic acid, when it is dissolved in water, it will form vinegar. So that means it is highly soluble in water, but solubility decreases with rise in molecular mass. This I told you the application in daily life, right? But let us see why lower masses are more soluble in water. The reason is because this is RC double bond O, this is OH, right? This is another molecule of RC double bond O, and this is H. You can also write it like this. C, this is OH. So write it like this. C double bond O, and this is H. Here what you can see, there will be hydrogen bonding between the molecules, right? Between the molecules. That is why the boiling point, I'll talk about the boiling point also. Firstly, let us see for solubility, we need to see the hydrogen bonding with the water. If you talk about water, here this water molecule will have hydrogen bonding with this hydrogen, right? One more water molecule will have hydrogen bonding with this water molecule, right? Then you can also have hydrogen bonding with this water molecule, right? This is O, this is H. This water molecule can also have hydrogen bonding here. So it's saying that there are so many cases of hydrogen bonding, right, with the carboxylic acid and water, right? That is why they are highly soluble in water. But when you increase this alkyl chain, for example, this chain is increasing, this chain is really large, then it will be very difficult for these water molecules, right, to form a hydrogen bond, right? That is the reason more is the molecular mass, more is the alkyl chain, lesser will be the solubility. That is why lower are highly soluble, but higher molecular masses are lower solubility. Lower members are highly soluble in water, but the solubility decreases with increase in the molecular mass here, right? Okay, yes. Now next is carboxylic acid exists as dimer in the vapor phase or in the aprotoic solvent. Aprotoic means which do not have any protons, right? Okay, so basically what we are saying, if you talk about the structure here, this is your RCOH molecule, one molecule. This is another molecule of water, another molecule of carboxylic acid, C double bond OH. This is one more molecule of carboxylic acid. Wait a minute, this is O. This is water only, right? This to they have shown water with water, na? This to they have shown with water. Let us form the dimer here, okay? Let us form the dimer. Dimer is not formed here, okay? Let us form the dimer, okay? Let us form the dimer here, how they are existing as dimers. So this is C double bond O, C double bond O, and this is OH, right? OH. Then you have another molecule that is R, C double bond O. This is O and this is H. Now what you will see, this will have hydrogen bonding here, right? This will have also hydrogen bonding here, right? Both of them will have the hydrogen bonding here, right? This molecule will have hydrogen bonding, this molecule will have hydrogen bonding. Two molecules, when they are hydrogen bonded and they make a cyclic structure, that is called dimer. Because this is, that is why we are saying carboxylic acid exists as dimer in the vapor phase or even in the aprotoic solvent, right? So now next thing we are saying is boiling points of carboxylic acid are higher than those of alcohol. Reason being, because some of the molecules are existing as dimer, it is very difficult to break a dimer, right? So alcohol has same molecular masses due to intermolecular hydrogen bonding, right? Okay, so that was the physical property about the solubility. Now let us see what are the chemical properties of carboxylic acids. So everybody ready for the chemical properties or not? Are you guys ready for the chemical properties or not? Shreyansh, you do one thing, okay? All the queries that you have for this one, what you can do, you can just text me on Telegram, Diksha Kaushal Chemistry Official, right, on my Telegram channel. Then we can talk about this thing, right? Okay? Yes. Now, Let us see the formation of anhydride, right? How the anhydride is formed from carboxylic acid by the elimination of water in the presence of P2O5 with the heat, or you can say in acidic medium and heat, right? Now what you are going to do, the one molecule is going to lose OH negative, one molecule is going to lose H positive, right? And hence this carbon and this oxygen will make a bond with each other, and hence you will have the formation of CH3, C double bond O, O, C double bond O, CH3. That is the anhydride will be formed here, and this is how anhydride looks like. And this anhydride is called ethanoic because it is formed from ethanoic acid, so it is called ethanoic anhydride, right? So that is the first reaction. Carboxylic acid heated with mineral acids such as H2SO4 or with P2O5 give corresponding anhydride here, right? So basically these are a good dehydrating agents. Dehydrating, whenever you want to have dehydration, these are very good dehydrating agents, right? When you want to have dehydration, these are very good dehydrating agents, right? Okay. Next is esterification. In esterification, right, very simple. What will happen? You will have carboxylic acid, you will have R-OH, right? So now, in this case, what will happen, right? In the acidic medium, right, what will happen? Here OH will leave, here H will leave, and you will have the, this is important to know that here OH will leave and here H will leave. That is how water will be eliminated from here. Not OH from here and H from here, right? Cramming the full mechanism is not important for you. What is important for you to understand that here OH will leave and here H will leave. From carboxylic acid, OH is going to leave, right? And hence you will have the formation of this will leave and this will leave. You will have RC double bond O. Here you had OH, it is going to leave, and you are going to attach OR dash here, right? How this thing is asked, they will ask you something like this. You have RC double bond O. Here oxygen is in the 16 isotop. This is in the 16 isotop, right? Plus you have R dash O. This is in the 18th isotop. Now you need to tell me what will be the answer. This way they can ask you the question, okay? Right? This way they can ask you the question. Now, as you can see here, OH is going to leave from this side, H is going to leave from this side. So answer will be RC double bond O. This is O, this is R dash. But what about the oxygens here? Definitely this oxygen is same as 16 only. But this oxygen is from alcohol, that is 18 oxygen, right? So these kind of questions they can ask you, right? Okay. Yeah, this is what I am telling you. Mechanisms are important, but you need to understand where the how they can ask you questions from the mechanism, right? Just cramming the full mechanism and you are not able to answer when they ask you the question out of it, then there is no use of cramming the mechanism, right? So from the mechanism, I know that OH is eliminated from this side and H from this side. From that, application is this thing. This is the application of that mechanism. So you need to understand the application of those mechanisms, how they can be asked, right? Okay. How 18? Because I am assuming that here they have given you 18 isotopes. There are two isotopes of oxygen. One is 16, one is 18. So I am assuming that in the carboxylic acid you have 16 isotop and in the alcohol you have 18 isotop. Now I told you the answer will always be that OH will be eliminated from carboxylic acid and H will be eliminated from this side, and these two RCOOR, this ester will be formed. Now they have given you that this is your carboxylic acid, this is alcohol. I know that this thing will be eliminated and this thing will be eliminated. So you will have what kind of elimination? You will have H2O, and this oxygen in the water will be 16. This is 16th isotop. So that is how here you will have O16, and here which you will which will be attached, that is oxygen from alcohol, that is O18, right? Is that clear to everybody here? Is that clear? Is that clear? Now let us see the mechanism here, how this happened, right? Now let us see the mechanism here, how this happened, right? Now as you can see here, you don't need to cram the mechanism. I'm again telling you, you don't need to cram the mechanism, right? That is just for your knowledge. I am telling you that why I told you that OH will be eliminated from carboxylic acid. What is the exact thing that are happening here? So you have carboxylic acid, you have H positive, right? Okay. Now we know that this is carboxylic acid. So what is going to happen? This is your electronegative, this is electropositive, right? Now this H positive is going to attack here, right? Because this is these are also having lone pairs. So it is going to attach here, and now it will have 3 bonds. That is why there will be 1 positive here, right? So that is why we have written 1 positive, not over here. The positive will not be on hydrogen. The positive will be on the oxygen, right? The positive will be on the oxygen, right? There will be positive on the oxygen. Now we know that this oxygen positive is not so stable. Oxygen is an electronegative element. It cannot handle a positive charge. It can handle a negative charge very easily, right? But it is not able to handle positive charge. That is why it will try to take out the pi electrons, because pi electrons are loosely bound. They are delocalized electrons. That is why it is going to take out pi electrons from this double bond to itself, right? Now what you will see that, ma'am, this carbon, when it is going to take away the pi electrons, this carbon will have OH here, it will have R here, and this will be positive. Ma'am, is this thing will be formed? I am saying no, right? There is no carbocation as such formation here, right? There is transition state. You will see that as soon as the pi electrons are moving here, it knows, this carbon knows that it will become electron deficient. So it will try to take the electrons from the outer side of the alcohol, right? So alcohol also have lone pairs of electrons. It will try to attack on this carbon, which is, we know that, okay, I told you breakup story, love story, okay? Love story is that this is carbon, right? This carbon, and this is in relationship with this oxygen. Now what will happen when these lone pair are going to attack? When they lone pair are going to attack? When they will say that the breakup is going to happen soon, right? So there is no, it's not like firstly the oxygen will go, right? Breakup will happen. Then another oxygen will try to, right, attach to this carbon. This will not happen. Here no carbocation is formed. No crying phase is there, right? Here the breaking up is happening. It is breaking up with this carbon, and this lone pair are attacking on this carbon. Simultaneously this thing is happening here, right? And hence you will have on this carbon, you will have one OH over there, and you will have O positive R. Now O positive R, why, ma'am? Because see, when you have this RCOH here, OH here, then this OH and R is attached here, because this from oxygen, this is attaching to this carbon. Now because oxygen has again 3 bonds, that is why it will have a positive charge, right? Okay. Now let us see again what is going to happen. Now oxygen is not able to handle the positive charge here, right? So what it will do, it will try to take the electrons from this hydrogen, and hydrogen will be eliminated from this side, right? And this will be transferred internally, right? How the hydrogen is transferred internally? This hydrogen here, that is present here. This hydrogen is transferred internally, and this hydrogen is transferred internally to which side? This hydrogen is transferred internally, wait a minute, to this side, right? It is transferred internally to this oxygen. And do you remember this was the oxygen? Which oxygen? This OH, this OH, this OH. I am saying the OH of the carboxylic acid is going to internally transfer. This hydrogen is going to internally transfer on the OH of the carboxylic acid, right? And that is how it will become OHH. That means it will become something like this. That means it will become something like this. Wait a minute. It will become, this is your O, this is your O, and here what you will have, and here what you will have H here, you will have H here, right? That is why again oxygen is having 3 bonds. That is why oxygen is positive here. Now again what will happen, because oxygen cannot handle positive charge, oxygen is going to take electrons and get eliminated as water. That is why I was saying that the carboxylic acid, the OH of the carboxylic acid will be eliminated. This is OH, this is OH, this is OH. It is as it is. Now in the next step, we will see that this OH has become OH2. Now in the next step, this O, oxygen of the carboxylic acid, that is the main point here. That is why I am again and again saying, remember the full mechanism, and don't knowing the main point of that mechanism is of no use, right? So here you need to remember is the OH of the carboxylic acid is eliminated here, right? And hence all the things will be same. Then one hydrogen will be internally transferred here, then the electrons will jump here, and hence you will have this reaction, that is your ester will be formed in the end, right? Okay, understood this thing? Right, everybody? Right, everybody? Lokesh, this is English channel, Vedantu JEE English, right? So that's why I'm speaking in English, right? Okay, guys, everybody in the chat box, is there any confusion? Is there any confusion? Yes, everybody, let me know in the chat box if there is any kind of confusion related to this mechanism. Now, next thing is, reaction with PCl3, PCl5, SOCl2 is very simple. Just the way you used to replace OH with RCl. You used to replace OH with Cl. Same thing we are going to do here. Here instead of ROH, you have RC double bond OH. That is why this will be replaced by RC double bond OCl. Right? That means OH is replaced by Cl. Just the same way that we have done in alcohol as well, right? So SOCl2 is the better reagent because now they are saying that even if you talk about PCl3, OH will be replaced by Cl. PCl5, OH is replaced by Cl. SOCl2, OH is replaced by Cl. But why SOCl2 is the best reagent out of this? Because the reactants, the side products that are formed is SO2 and HCl. And both are in the form of gases. That is why the byproducts are vapors, right? That is why it is very easy to form a pure compound is produced here, right? That is why SOCl2 is preferred here, right? Now, SOCl2 is the best reagent because byproducts of the reaction are gases which are easily separated, right? And this is your reaction. As you can see, OH is replaced by Cl, OH is replaced by Cl, OH is replaced by Cl, and the byproduct, this is the same reaction that we did in haloalkanes, halurines. It's just that there we did for ROH, we converted it to RCl. Here we did it for RCOOH and we converted it to RCOCl, right? That is the only difference that we can see here, right? Okay, okay guys, everybody, is that clear? Okay guys, now reaction with ammonia. Now you have carboxylic acid, this is also important reaction. Carboxylic acid react with ammonia to give ammonium salt, right? Now let us see how. Now you have COH, that means this thing you will have, right? This thing you will have. Now when you add NH3 here, what will happen? This H positive, we know that ammonia is a base, right? Ammonia is a base. Now, what is the quality of a base? A base wants to accept the protons or donate the protons. A base wants to accept the protons. So, here what will happen? You had RCOH and you had NH3. We know that ammonia is a base. It will try to take the H positive. It will try to you will accept the H positive, accept the proton here, and it will become O negative here, and it will become NH4 positive here, right? These are the things that you will see. It will become NH4 positive here. Is it? Now, this is RCO negative, this is NH4 positive. Now, this is negative, this is positive, that is why they will make a bond here, right? That is the thing you will use, and this is called ammonium acetate, right? And this thing is called ammonium acetate. I told you how this thing is formed. This is called ammonium acetate. After taking out water from here, from where? You will take out oxygen, one oxygen and two hydrogens from here. It will become NH2. right? And hence you will have the formation of amide here, right? Hence you will have the formation of amide. So basically you can say on reaction with ammonia, OH is replaced by NH2. That is called when you form amides from carboxylic acids, right? When you form amides from carboxylic acid, how this is formed, that also I have shown you, right? So this is basically, this is already shown you that here also OH is replaced by NH2. Firstly, what will happen? This COH will be converted to COOO, NH4, this is positive, this is negative, right? And after losing water here, it will be converted to NH2 here. It will be converted to NH2 here, right? Guys, wake up, wake up, wake up. Wake up. I think I should behave like a watchman, no? Jagte raho, wake up. Now, next is very important. This is actually a very, very important reaction, right? So basically, here reaction with ammonia, this is your phthalic acid, right? Phthalic acid, how this is converted to phthalimide. Now this phthalimide will be very useful when we will do amines, right? When we will do the next chapter, that is your amines chapter, right? So this phthalimide will be of very high usage for you, right? Because we have a reaction called Gabriel phthalimide reaction, which is based on, this is the initial product of that reaction, right? That is why this reaction also becomes very important for you, how to convert phthalic acid to phthalimide, right? So when you talk about phthalic acid, you have added ammonia here. Basically what will happen, this COOH will be converted to COO negative NH4 positive, right? Again this is COO negative, this is NH4 positive, right? This thing will be formed, and this was what we have written here. After this, water will be eliminated. So you will have NH2 here, you will have NH2 here. Now next step is very important. From this NH to NH2, right? After using strong heating, what will happen? You will lose ammonia from there. NH2 from this side and one hydrogen from this side. That means NH2 will be, you will lose, and one hydrogen you will lose. So what you will have? NH here. So it will be called as, this is N, this is H, and this is definitely your benzene that you had formed here, right? So that becomes your phthalimide, okay? That will become phthalimide, okay guys? So that will become phthalimide, okay? Okay, ma'am, not clear. Okay, let's do it again. Okay, chalo. So this is your COH, right? This is C double bond O, OH. This is C double bond O, OH, right? This is the benzene. Now what will happen here? Now what will happen here? I am just going to write not all the steps here. I am going to erase this and write the steps, okay? So because I just want you to understand, no notes so you already have. Now what will happen when you add ammonia? We know that what will happen? O negative and NH4 positive. This is O negative and NH4 positive. This is the same thing that we are doing, right? Here we did the same thing, no? This is converted to COO negative NH4 positive. The same thing I am doing here, right? Then you will eliminate water from this side. Water from this side you will have NH2, right? Water from this side you will have NH2. Basically, what you need to remember, when you have carboxylic acid groups and you are adding ammonia, then that OH is getting converted to NH2. You can just simply remember this thing, right? Now, after this, on strong heating, you will have elimination of NH3. NH2 from this side and one hydrogen from this side. What part is left? NH part is left. So you can write it like this. This is NH. And this is called phthalimide. And this is called phthalimide. Now tell me, is this thing clear to all of you? Right? Is this thing clear to all of you or not? Okay. This is called phthalimide. Two things I did. Firstly, what I did, there was OH. there was OH here, OH here, right? When you add ammonia, OH is converted to NH2. That is 2 amide group you have. Now, after strong heating, you will have release of ammonia. NH2 will be eliminated from this type, H will be eliminated from this one, and hence this thing will be formed. And this thing I have written it like this. Okay, in books you will see it like this, right? Okay, very good. Now, next is reduction. Just give me a minute. Wait. Yes. Now, next is reduction. If you talk about reduction, reduction is inverse of oxidation, right? So, we know that from alcohol, we had aldehyde and ketones. We had aldehyde and ketones. And after further oxidation, we had carboxylic acids, right? So, this was the relation when we had oxidation. When we do the opposite of this thing, what we are going to have? Opposite of this thing, this is reduction, this is reduction. Now, it depends on whether you have strong oxidizing agent, you have weak oxidizing agent, to what extent it will be oxidized, right? So, carboxylic acids are reduced to primary alcohols. Can you tell me why I am saying primary alcohols? Everybody in the chat box, see one thing. We know that let us take the example of primary alcohols. We know that when we talked about oxidation, we talked about that this is your COH, right? Or you can say this is CH2OH. This is your primary alcohol, right? I'm writing it here. This is your primary alcohol. We know that when you do mild oxidation, 2 hydrogens are converted. Here, this OH is converted to double bond O, so it will be CH, or it will be converted to double bond O, and this is H. Now, with further oxidation, this H is converted to C double bond O, right? So, it is like this. It is converted to, this H is converted to OH, right? This H is converted to OH. This is primary alcohol. This is primary alcohol, right? That is converted to aldehyde, right? Aldehyde, which on further oxidation is converted to carboxylic acid. Carboxylic acid, right? Which on further oxidation is converted to carboxylic acids. So, if I do the reverse of this thing, can I say that if I reduce carboxylic acid, that will be mild reducing agent, will be converted to aldehyde. With strong oxidizing agents, it will be converted to primary alcohols. That is what they are saying here. That acids are reduced to primary alcohol by lithium aluminium hydride. Now, they are talking about lithium aluminium hydride or diborane, that is B2H6 or LiAlH4, right? Now, LiAlH4 and B2H6, these are very good reducing agents. That is why they are able to reduce carboxylic acid directly to primary alcohols, right? Carboxylic acid directly to primary alcohols, they are not stopping at the stage of aldehydes, right? Okay. Next is, this is what they are. Now, here you have LiAlH4 with ether or with ether or B2H6. It is converted to primary alcohol. Here as well, it is converted to primary alcohol with same number of carbon atoms, right? Okay. Now, one thing to note here, we have not used sodium borohydride because sodium borohydride is not able to convert carboxylic acid, right? It is not able to reduce carboxylic acid. That is why we have not used it there, right? That is why we have specified that we will use lithium aluminium hydride or diborane, right? Okay. Okay, guys. Next is decarboxylation, soda lime decarboxylation they are using, talking about. This too we have done so many times. Soda is what? Soda. What is caustic soda? That is NaOH, right? What is quick lime? That is CaO. So, we are going to use these two things, that is caustic soda and quick lime, that is called soda lime decarboxylation. What you will have? You will have RCOONA, and this will be converted to, on using soda lime, this will be converted to RH. That is the alkane that you will see here. right? So the reaction of carboxylic acid loses CO2 is called decarboxylation, right? And firstly, so you have soda lime decarboxylation, where you will add NaOH and you will add CaO, where CaO is the catalyst, and what you will see, it will be eliminated as Na2CO3, right? Na2CO3, right? Because this is your, this thing will be eliminated and this hydrogen will be attached to this R. This is Na2CO3. That will be eliminated and you will have the formation of one carbon less alkane, right? One carbon less alkane. Next is, this is soda lime decarboxylation. What you had the formation of one carbon. This will be eliminated. You had the formation of one hydrogen will be attached here. You had the formation of CH4. Right, and it uses, and it uses free radical mechanism, right? It uses free radical mechanism. I hope so that you have done this in your hydrocarbons, right? Because there though it is in detail, right? So if you have not done that, then do let me know about it. Free radical mechanism, it follows free radical mechanism. That is why the questions are slightly same as Wood's reactions only, right? Okay. Then we have next is Cole's electrolysis. Here also you will have decarboxylation, but this happens via the formation of intermediate is carbocation, carbanion. This is also in detail in hydrocarbons, right? This also is in detail in hydrocarbons. So this is your carbanion. Now see one thing here, that if you talk about this, if you have RCOONA, after Cole's electrolysis, you will have the formation of RR. That means you will eliminate this CO2 will be eliminated, and the rest part R will be attached to one more R chain, and you will have double the number of the alkyl chain that is in your carboxylic acid, right? So for example, you had CH3CONA. This thing will be eliminated, double this thing, you will have CH3, hence CH3 is the answer, right? Okay, okay guys. Next thing is sodium or potassium salt of carboxylic acid on electrolysis give alkane, right? Okay, sodium or potassium salt will give us alkane. Second thing is alkane formed at anode containing even number of carbon atoms, right? You will always have even number of carbon atoms because that will be always doubled, right? Okay, okay everybody. Okay everybody, everybody in the chat box, right? Is that clear? Is that clear? Is that clear? No response, ma'am. Ma'am, you say, you whatever say, we will not give you any response, ma'am. We are very stubborn, ma'am. No matter what will happen, we will not give any response. Is it? That's the attitude that you guys are carrying, huh? I don't understand, yeah. Why you guys don't, why such laziness, huh? Next is Helvohar-Zelensky reaction, that is HVZ reaction. So in this, basically what will happen, this alpha carbon, this is your carboxylic carbon, and this the carbon attached to it is called alpha carbon. That alpha carbon will have the substitution of the halogen that you have added here, right? And that halogen is added in the presence of red phosphorus, and after the hydrolysis you will get mono-halo substituted product, right? That means on the alpha position, one hydrogen will be substituted by a halogen, and this is what you will get, and this is called Helvohar-Zelensky reaction. The alpha hydrogen atoms are highly reactive due to presence of electronegative this group, right? Alpha acidic hydrogens are reactive. That is why aldol condensation was happening. That is why in the presence of base it was happening, right? So here alpha hydrogens are hydrogenated at the alpha position on treatment with chlorine or bromine in the presence of red phosphorus, right? And you will have the alpha halocarboxylic acid. On the alpha position, you will have halogen, right? On the alpha position, you will have the halogen. Now, next is chemical properties, right? Next are the substitution reactions. So substitution reactions basically, as I told you yesterday also, that when you talk about aldehydes, right, that was also meta-directing. Here this will also be meta-directing. The reason being you have C double bond O, this is OH, right? Now can you see this thing here? That again oxygen is more electronegative as compared to carbon. That is why it will take out pi electrons from here, pi electrons from here. Positive charge will be on ortho and para position, and hence meta will have slightly negative charge, more electron density. That is why as it is taking out the electron, it is showing minus M effect and it is meta-directing, right? Why? Because it has more electron density on the meta position. So towards electrophilic substitution reaction, it is meta-directing in nature. Carboxyl group act as deactivating because it is taking out the electron, and a meta-directing group because electron density is more on the meta position. Then we have aromatic carboxylic acid undergo electrophilic substitution reactions, right? Electrophilic attack on the meta position you will see, right? On the meta position. Let us see, and there also you will see one exception, right? So here first is when you have nitrating mixture. Here as we know that the electrophile that is formed is NO2 positive. Now this electrophile is going to attack on the meta position because COH group is meta-directing, hence you will have meta-nitrobenzoic acid will be formed, right? If you talk about Br2 FeBr3, again which will be the electrophile, Br positive is the electrophile that is going to attack on the meta position, and hence you will have meta-directing, that is meta-bromobenzoic acid will be formed here, right? Next is very important line. This line, the question can be asked from this line, right? That they will not show Friedel-Crafts reaction. Whether you talk about Friedel-Crafts alkylation or acylation, they will not show those reactions, right? What is Friedel-Crafts reactions? When you add any alkyl chloride or acyl chloride in presence of AlCl3, right, anhydrous AlC, that is called Friedel-Crafts acylation or alkylation. Now why they will not show? Reason is because this is your carboxylic group, C double bond O, this is O and this is H, right? So carboxyl group is a deactivating group, and the catalyst aluminium chloride, right? You can use AlCl, this is your anhydrous AlCl3, aluminium chloride they are talking about. This is a Lewis acid, right? This is a Lewis acid. So what it will try? It will try to, here it is a Lewis acid. What is a Lewis acid? Basically it has deficiency of electrons, right? We know that electrons are more over here, right? We know that it is C double bond O OH, right? The electrons are delocalized here. The electrons are moving here. That is the reason this Lewis acid will attack on this carbon rather than making an electrophile with this RCl and RCOCl. It will attack on this carbon directly. That is why the Friedel-Crafts reaction will give some another product only. Right, so aromatic carboxylic acid does not give Friedel-Crafts reaction because the carboxyl group is deactivating and the catalyst aluminium chloride gets bonded to the carboxyl carbon. That means this carbon, it will get bonded to this carbon because of the delocalization of electrons on this carbon. This carbon now also has electrons. That is why this Lewis acid is attracted towards those electrons. Right? Okay, guys. Okay. Now we are going to start with the previous year questions. So let us see how many questions you are able to answer. Shall we start? Everybody in the chat box, shall we start with the previous year questions or not? Everybody in the chat box, are you ready? Ready, steady, India, go. Questions though I can't teach myself. No, question though you have to respond. Yes. Now, match the list number 1 with the list number 2, right? You have to match these two lists. So, if you talk about the list number 1 and this is list number 2, so First is CH3, CH2, some normal chain. Then you have this, first just remember one thing. This is the ester group that you can see. It is converted to aldehydes, right, with the same number of carbon atom, right? So what we can use here? What we can use here when you want to, this we have done in the preparation of aldehydes and ketones. There I told you, then if you want to convert ester to aldehyde, right, then you will use DIBAL, diisobutyl aluminium hydride, right? This is what you are going to use. So to convert ester to aldehyde with the same number of carbons that were here, right, what you will use? You will use DIBAL, right? So one is, so A is for fourth one, right? Then you have, this is RCOR. So this basically is ketone. Here ketone is converted to, basically this was C double bond O, and here it is converted to 2 hydrogen. That means 2 hydrogen. That means reduction is happening, right? So when you have C double bond O is converted to CH2, then we call it, what is happening here? Then we call it what? Then students, we call it what? Then we say that basically we added, right? Either it can be Clemmensen reduction or it can be Wolff-Kishner reduction, right? So let us see what you have. Wolff-Kishner reduction you don't have in the options. You have Clemmensen reduction, that is zinc amalgam and concentrated HCl. So answer will be, for B you will have 2, right? For B you will have 2. Third is, right? Third is ring substitution. Okay, after this question I'll teach, right? Now here you have aldehyde and this is converted to alcohol. That means again reduction is happening. But if aldehyde is converted to alcohol, but here can you see one thing? Can you see one thing here? This is C6H5, basically it is C6H5, CHO, right? That is converted to C6H5. This is C, this is C6H5, this is CHOHCH3, this is CHCH3 and this is OH. Can you see this thing here? Everyone, can you see this thing here? Can you see this thing here? This is COH and this is CH3. So now here, can we confirm that there is increase in number of carbon? Increase in number of carbon. Right? There is increase in number of carbon. So the options that we are left with is NaBH4 and CH3 MgBr. So definitely reduction is happening. Then if you have any Grignard reagent here, then definitely it is going to increase the number of carbons. How? How it is going to increase the number of carbons? If you want to make, if you want to make this product here, if you use CH3, if you use CH3 MgBr, definitely this is positive, this is negative. This negative is going to attack here and the electrons are going to jump here, and what you will have, here you will have, this is benzene, this is benzene, this is double bond, double bond, double bond, this is C, O negative, this is hydrogen, and this is CH3. To this O negative, you will have the attachment of MgBr, right? After hydrolysis, this OMgBr will be converted to OH, and hence you will have the formation of this product. Then we can say definitely for C, it is Grignard's reagent, right? So here answer will be, for C, it will be first. That is Grignard reagent. Till now we know that A is for fourth, B is for 2, and C is for 1, right? Then definitely D is for third. But still we will see that. Here you have COCH3, basically it is a R chain, then you have CO, then again you have a carbon, then you have COOC2H5. But here, very important thing, this is the ester group. This is C double bond O and O. This is R and this is also R. Ester group is not reduced by NaBH4, right? ester group is not reduced by NaBH4, but ketonic group is reduced by NaBH4, that is sodium borohydride. That is why here CO group is converted to alcohol, but this group is intact. That is why we can say that definitely D is for 3. So answer is A4. Answer is A4, B2, C1 and D3. That is second will become the correct answer. Right? Okay. Okay, guys. Good evening, Rama. Good evening, Rama. Good evening. So, is that clear to everybody? That second is the correct answer, right? Okay. Next is you have monochlorobenzaldehyde. Monochlorobenzaldehyde on treatment with 50% KOH solution yields which thing? Now, everybody try to answer this. Try to answer this question. Try to answer this. Firstly, make monochlorobenzaldehyde. What is monochlorobenzaldehyde? Right? What is monochlorobenzaldehyde? This is benzene. Benzaldehyde means CHO group here. Monochloro nahi, it is metachloro. Metachloro means chlorine here. Right? Firstly, I can sense that there is some aldol or Cannizzaro reaction, right? Because they are using 50% KOH. Now, it does not have any alpha hydrogens. No alpha hydrogen. That is why definitely it is a Cannizzaro reaction. Definitely it is a Cannizzaro reaction. That too we are sure about. Right? That too we are sure about. Now, if I say you are having a Cannizzaro reaction, one thing is converted to alcohol. That means here it is converted to CH2OH. That will be the first product. Second product will be the same thing is converted to carboxylic acid salt, that is COONA. Right? So where you can see this COO, this is meta only, na? Because for it is ortho, this is meta, this is para. Right? And here it is meta only, this is CH2, this is CO. So second will be the correct answer. Right? So second will be the correct answer. Right? Okay? Second will be the correct answer. Right? Okay? Yes. These are all your previous year questions only. Right? Next is identify the name reaction. You have to identify the name reaction here. Very simple. This so you can just tell in just 1 second. I want you guys to answer this. Yes, everybody answer this. What is the name of this reaction? What is the name of this reaction? What is the name of this reaction? Very good. Getterman-Koch reaction. Very good. The answer is Getterman-Koch reaction, because we are not Getterman. Getterman reaction is a different reaction. This is Getterman-Koch reaction, right? Where benzene is converted to benzaldehyde in the presence of COHCl and anhydrous AlCl3 or CuCl, right? Next is, two statements are given to you, right? First statement is acidity of alpha hydrogens of aldehyde and ketone is responsible for aldol reaction. Definitely, in aldol reaction, you must have alpha hydrogens, only then aldol reaction will occur. So that is true. Second is reaction between benzaldehyde. What is benzaldehyde? This thing. What is benzaldehyde? CHO. And ethanol. What is ethanol? CH3C double bond OH. Will not give cross aldol. Now here the students can get confused. Why? They'll be like, ma'am, this will give Cannizzaro, ma'am. As a why? Ma'am, because this does not have alpha hydrogen. But students, this too has alpha hydrogens. No, this has alpha hydrogens. Right? This has alpha hydrogens. So that is why here it will not give you Cannizzaro product. It will give you aldol product, right? That is why, because it has two products here, that is why we will say that it will give cross, it has two reactants, that is why it will give us cross aldol product, right? Okay, so answer is aldol product is formed, so that is why this is the false statement. and hence statement 1 is correct and statement 2 is incorrect. So 1 will become the correct answer, right? 1 will become the correct answer. Why? Because this has alpha hydrogen, right? This does not has, right? So that is why aldol will happen here. Next is very important reaction. Identify the product in the following reaction. So a reactant, a very cute, or you will say very weird reactant is given to you. They are saying you have ZnHCl. Firstly, just tell me what is this reaction? What is the name of this reaction? Yes, Saran, the only solution that you need to have is give the practice test, give the mock test, then identify where you are lagging behind, right? Are your basics not clear, right? Is there like some specific topics or specific subjects that you are weak in, right? You have to identify. If you're overall weak, that means you need to work more. If there are some specific topics and some specific subjects where you are working, that you need to work on those topics, right? Okay, yes, very good. That is Clemenzin reduction, right? That is Clemenzin reduction. Now I told you in Clemenzin, right, whether you have aldehyde or ketone, both of them will be converted to hydrogens, right? So here also you will have 2 hydrogens. Here also you will have 2 hydrogens. So here you will have CH3, right? CH3 will be formed. And here CH2, CH3. That means first will be the correct answer. Is it? Why first and second are same only? Wait a minute. Am I saying the right thing? First and second are same only, no? This is the correct answer. This you can variate something here, right? Chalo, let's do this. Okay? Let's do this. This first and second were the same figures only, right? Maybe some typing mistake. Okay? So 1 is the correct answer. Okay? Got it? Got it, everybody? Yes? Yes, okay? Now, next is this. So let me change the structure here. Now they are asking you the number of C. The questions are, these are all your previous year questions only. The questions are not very difficult, right? And right now, firstly, let me tell you one thing. So many students are asking, ma'am, are you also teaching us regarding advanced? So firstly, crack means I am teaching you the basics as well. I am teaching you the theory of like JEE means and advanced, but the advanced questions have more level, right? That is why once we are done with the January shift, after that we will start with the, not start what I would say, we will do the practice questions of the JEE advanced, right? Because right now the main task, if you are not able to clear JEE means, and how you will be sitting, how you will sit in JEE advanced, right? So JEE advanced, the strategy is, firstly let us do the previous year questions of JEE means. The theory part is same only, right? The reactions that will not be asked to in JEE means, I am covering those also, right? It will not be a surprise to you. You don't have to prepare again for JEE advanced, but yes, the practice will be based on JEE advanced question once you have completed your means, right? Okay. Now, see this question it is, the number of correct reactions among the following is. Now see 4 reactions they have given you. First is you have benzene COCl, anhydrous Cl3. Definitely this kind of electrophile will be formed, right? Which electrophile will be formed? This electrophile will be formed. And this electrophile is going to attack here, right? Hence you should have, the answer should be, this is benzene, here CO, and this benzene ring is going to attack. Hence, this should be the answer, right? Benzophenone, right? Benzophenone should be formed here. That means this is not correct. This is not correct. Next is COCl with H2 PD. This is Rosenmund reduction. This is Rosenmund. And here definitely we can see that Cl is, no, that is also incorrect. In this Rosenmund reduction, this COCl, it should be replaced by C double bond OH, right? It should be replaced by C double bond OH. So that is also the wrong answer. In Rosenman reduction, what we did, this benzene, this is C double bond O Cl, this was converted to this benzene C double bond O H, Benzaldehyde. Do you remember that? Yes. Now, next is you have, this is Gatterman-Koch, this is Gatterman-Koch reaction only, where benzene is converted to CHO. That is the right answer. They are asking the correct answer. So this is why you are saying second is the correct answer. Third is the correct answer. Because here it is converted to COH, right? We need to, if you have using Rosenman reduction, then this COCl should be converted to CHO, right? So this is the incorrect answer. They are asking you which is the correct reaction among these, right? So first is also incorrect, second is also incorrect, third is correct, right? Now this is basically multiple choice question, right? So if you talk about CONH2 on hydrolysis, it is converted to NH2. That is also not right because it is converted to COH. Amide on hydrolysis is converted to carboxylic acid, right? Okay, so that is the answer. Here this is also the incorrect answer, and here the answer should be CHO. So this is also the incorrect answer. So the correct reaction is C, right? Correct reaction is C, right? Okay. Okay, guys. Yes. Okay. Shall we move ahead? Okay. Now C is the correct answer. Next we have identify A in the following reaction, right? So now firstly tell me what is the name of this reaction? Everybody, what is the name of this reaction? I'll give you a hint. It is somewhat related to Clemmensen reduction. Ma'am, is JEE only for NIT and IIT or any other colleges? Ma'am, please tell. I'm currently studying in 12th. So see, basically for IIT and NIT, right, the only thing that you want to get into that, you have to go through this exam, right? Now, second thing is if you talk about state colleges, right, if you talk about other colleges that are in your state, for those, there is criteria of different colleges. Some colleges, most of the colleges, they will accept your result of JEE mains and advance, right? They will accept that. But some colleges will not accept it. They will have their own entrance exam, right? Like you have entrance exam of BITSAT, right? So you have to give that entrance exam and then you can get into that. But some colleges, they have their own entrance exam also. They can also give you admission based on JEE, right? So that also depends that which college you are thinking about, right? So you have to go to the site of that college and see how you can get enrolled into that, right? Okay. Yes, but I would advise you, apart from JEE, the syllabus is same only. There is no difference in that, right? Everything is same. Even the level would be lower than the JEE only, right? Okay, not lower, I would say same with JEE, not more than JEE. So if you're preparing for JEE, also give your state board exam, not board exam, state college exam, right? That are good state colleges that you have nearby. Mostly colleges of South are really good, so you can also apply for that, right? Okay. Now, here, identify A in the following reaction. Yes, this is called Wolff-Kishner reduction. Very good. This is called Wolff-Kishner reduction. Wolff-Kishner reduction. So in Wolff-Kishner reduction, right, you have hydrazine. This is nothing but basically this is NH2, that is hydrazine. So this hydrazine in basic conditions, here this carbonyl group is converted to 2 hydrogens. That means this thing is converted to 2 hydrogens. Where are 2 hydrogens? So here this carbonyl group is converted to 2 hydrogens. Hence the answer 4th is the correct answer. Such an easy question, right? They are asking you, right? Okay, such an easy question. Okay, what you just need to remember these things, right? But the task about organic chemistry is remembering the reactions, right? Okay, so now next is, which among the following aldehyde is most reactive towards a nucleophilic addition reaction? This also I have told you that more is the inductive effect, less is the reaction towards the nucleophilic addition. More is the steric hindrance, less is the reaction, right? So here you have 3 carbons. Here you have 1 carbon. Here you have 2 carbon. Here you have no carbon. So definitely there is no plus I effect. There is no steric hindrance. There is no steric hindrance, right? That is why, because here it is donating the electron. So carbon is like, I am already rich. Why would I want some nucleophile to attack on me? Here it is like, I have 3 carbons, bhai. I don't need you. I am already rich. Here it is like, I have 1, but I am still okay. But this thing, this poor person is like, I have no carbon, right? That is why I am very poor. Now nucleophile can attack on me. That is why 4th is the correct answer. They are asking you most reactive. No, yeah. So most reactive is 4th is the most reactive. If you talk about the series here, 4th will be most reactive. Then you will have 3rd. Then you will have 2nd, and 1st will be the least reactive among them, right? Okay, 1st will be the least reactive among them. Okay, guys, now what you need to do now? Okay, now next question, very beautiful, important question on your screen, right? Try to answer it yourself. Try to answer it yourself, right? At least try. What will happen maximum? You will get the wrong answer. Okay, but you will not get the wrong answer in the exam, because you will remember in your head that yes, I tried in the class. I was not able to answer it, but ma'am explained it to me. Now I remember everything, right? Okay, so that's why at least try. Okay, I am not going to judge you that this kid is answering wrong. At least that person is answering, right? Okay, so I like students who answer, right? So now first is Beer's test mark. So what is Beer's test for? Beer's test is for which thing? This we have done in hydrocarbons as well. That is a hint for you. Differentiating between alkane, alkenes. Now you can, I think you're able to like understand what hint I am giving you. Ceric ammonium nitrate test, what it is going to give you, right? Then we have phthalate dye test. This also we have done. Schiff's test also we have done. So yes, everybody. Yes, everybody. In the chat box. In the chat box. Shall we start? Shall we start? Yes. First option. Okay, very good. Now, if you talk about Beer's test, that marks for the unsaturation, right? You need to, that is a test for unsaturation. Bromine water test is a test for unsaturation, right? Beer's test is a test for unsaturation, right? Basically, here we used a KMNO4, right? So that is how we test unsaturation. Second is ceric ammonium nitrate test. So this is done in alcoholic group, right? So to identify alcoholic group, we use the ceric ammonium nitrate test. Next is phthalate dye test is used to identify phenols, right? Last is Schiff's test. This we have done in aldehydes, right? This is used to identify the aldehyde. So answer is A is 4th. A is 4th is, that means 2nd and 3rd cannot be the answer. B is 3rd. B is 3rd means this one. So this cannot be the answer. C is 1 and D is 2nd. Okay. So answer 1 will become the correct answer. Okay. First will become the correct answer. Okay, guys. Understood? Now one more question on your screen, that is match the following. Now again you have 4 tests. Now they have not asked you what is that test, what is the identification test. They are asked you what will be formed, how you will identify that this thing is present here, right? Okay, again try to answer that yourself. Okay, try to answer. Even if you know 1 or 2 options, now you will be able to answer this, right? Even if you know 1 or 2 options, try to answer it, everybody. Try to answer it yourself. Shabash. Everybody try, at least try. Yes, I am waiting for your answers. Tharun is saying, ma'am, is this 1? Okay. Okay, Tarun is saying no, ma'am, that was for last one. Here I am saying 4. Okay, here he is saying 4. Now, what about the other students here? Tarun is saying 4. Okay. Bromine water test, I've just told you in the last reaction, right? In the last question. Bromine water test is a test for unsaturation basically. And here which thing is formed? Red color appears, blue, green, red color appear, reddish orange color disappears, right? Definitely bromine water test. Bromine water vapors are reddish brown in color. So reddish brown orange color will disappear. That means A is for second, right? Then you have steric ammonium nitrate test. So what will happen in steric ammonium nitrate test? Yellow orange color, right? Yellow orange color, wait a minute. Yellow orange, this to we have done, na? Yellow orange color or red precipitates is formed. Then you have red color appears, blue, green, violet, red color appear. Now everybody tell me in the chat box what will be the correct answer. So red color will appear here, right? Red, that means B, can I say that is for third? Then you have ferric chloride test. Ferric chloride test. So what will happen here in ferric chloride test? Yellow orange, orange red precipitates, or these two we have done. Blue, green, violet, red color appear. Now what kind of color will be appeared in ferric chloride test? So in ferric chloride now you have sequence of colors. Firstly blue color will be, then green, then violet, and in the end red color will appear, right? So these are sequence of tests. So this is C is for fourth one, right? Then you have 2 for DNP test. Then we are just left with yellow orange or orange red precipitate is formed. So D is for first. So here answer is A for fourth. So that is in one reaction only. A second, B third, C fourth, and D one, right? So fourth will become the correct answer. Even if you don't know the other things, if you know just bromine water test, then you will be able to answer this, right? But we need to know all the things here, all the I would say all the test here, all the identifications here, right? So here answer is fourth is the correct answer, right? Which of the following compound, they are saying which of the following compound can give positive iodoform test when treated with aqueous solution followed by potassium hypoiodide, right? Everybody, which of the following compound give positive iodoform test when treated with aqueous solution followed by potassium hypoiodide, right? So now you want to have iodoform test. That means you need to have either CH3, either you need to have CH3, C double bond O, or you need to have CH3, CHOH. These are the two things that you need to have, right? So if you talk about epoxide, if you talk about this aldehyde, there is no CH3, CH2 group, CHO group. If you talk about this one, here also you don't have CH3, CO group. This is also not the correct answer. Let's talk about these two things. If you react this thing with potassium hypoiodide, what will happen? This will get converted to OH here. This will get converted to OH here, right? Okay, treated with aqueous solution followed by treated with aqueous solution. So when you treat it with aqueous solution, right? Then when you treat it with aqueous solution, then this Cl is replaced by OH. This we have done in the starting. Well, I'll just write it on the next page. You have CH3, you have CH2, you have CCl, then you have CH3, right? Now, on adding aqueous solution, the base here, what will happen? This Cl will be converted to OH here, right? So this is OH, this is also OH, and this is CH3. Once it is converted to OH, this OH, because carbon cannot handle two OH, right? So what it will do, here you will have oxygen, wait a minute, this is oxygen, just give me a minute, this is oxygen and this is hydrogen, right? Here what will happen, H positive will leave and this bond is shifted here. And hence what you will have here, this is CH3, this is CH2, C double bond O and H. Not H, this is C double bond O, this is CH3. Can I say this is my identification that iodoform test will give iodoform test, right? It will definitely give because it has COCH3. So directly they have not asked you that this is a reaction here, but this is a level of JEE, right? Okay, so directly they have not asked you the question, right? They have asked you, like ghuma fira ke. So this thing which students will be like, they will go very excited, they will like either tick this or they will tick this or they will tick this. They will not even look at the Cl, right? But Cl is going to, this vicinal dihalide is, this geminal dihalide is going to give you the answer, right? Okay. Okay, guys. Next is, which of the following compounds will give silver mirror ammonical, okay, the silver mirror with ammonical silver nitrate, right? So silver mirror is given by, very important, aldehydes. Second is formic acid also give tolerance test, right? This is important. So formic acid will give, formaldehyde will give, benzaldehyde will give, but ketone will not give it. So A, B and C, they will give tolerance test, they will give the positive tolerance test. Yes, students have written 3, right? Because usually students tend to forget that formic acid also gives positive, not any other acid, just formic acid, right? Just formic acid, this thing, HCOOH. Just this will give you positive tolerance test, right? Okay. Okay, guys, that is an exception here, right? Okay. Now, identify the major product P formed in the following reaction. Simple, I think this is very, very simple, right? Which thing will be formed? This is repeated only because they tend to repeat some questions, okay? So, the way they have asked the question is different, but the same question they are asking. So, this electrophile will be generated. It will attack on this benzene, right? Okay, it will attack on this benzene. Always when you are showing the attacks, or always it should be more electron density to less electron density, right? So here it is going to attack here, or you can draw this thing. It is going to attack here, right? And hence you will have the formation of, this is benzene. Benzophenone basically you will have. This is benzene, this is CO. Again you will have benzene. So fourth benzophenone will be formed. D is the correct answer, right? Okay. Next we have the azodide. This is a very, very important question. Okay. This is a very, very important question. So everybody in the chat box, try to answer it yourself. Try to answer it yourself. Sure, I'll just make one, I'll just give you one hint here. Azodide formed in the following reaction is sulfanic acid NaNO3 plus this is X. Now they are saying that X is formed by 3 things. One is sulfanic acid with NaNO3 and CH3COH. And what is this X? Now what is this X? X is this. Sulfanic acid means you will have SO3H here, right? Now because of this NaNO3 and acid, you will have N double bond N here, right? Then you will have OC double bond OCH3 because of the acetic acid. This is a very, very important question, okay? It's a good question, right? That's why I say in your competitive exam, you will find very simple questions as well, like good tricky questions as well. So this is one of the good questions that I would say, right? So this is N double bond OCOCH3, right? This is called X. and now it is introduced with this NH2. Right, here you have NH2. Okay, can I just rotate this thing? Can I just make this in a different pattern? Can I just form this thing as, this is SO3H and this is N double bond N O C double bond O CH3, right? Now, here you have this, right? And you react this with benzene NH2. Then again here you have one more benzene ring you have here, right? Double bond, single bond, double bond, double bond, right? Now this is the thing that you have. Now what will happen? What will happen? The para position of opposite to this NH2 and this azo, this group, they will attach with each other. That is called azodide. Okay, so what they will form? They will form, this is benzene, right? This is SO3H, right? And here you have N double bond N. This whole thing will be eliminated with this hydrogen and you will have the elimination of CH3, COOH, right? And after this you will have C, this is NH2 and there is one more benzene ring that is attached. So this azodide that is of red color will be formed, right? Okay, azodide, this kind of compound is formed. Is that clear to everybody? Yes, this red azodide is formed. If you have any problem in this question, because it was a different question that we have done previously, right? Is there any problem here? Is there any problem here? Now, here, which thing is formed? You have SO3 N double bond, this fourth one, this is formed. SO3H, benzene, azo, N double bond. Then you have this benzene, NH2 and this benzene, right? So fourth is the correct answer, right? Okay. Very good. I think how many questions? Last question that you have. This is the last question of today. Let us see how many of you are able to answer this. Last question of today. Let us see how many of you are able to answer this. The question says that identify the product P in the following reaction. Right? They have given you Br2 red phosphorus. Easy. Tell me what is the name of this reaction. Yes? What is the name of this reaction, everybody? What is the name of this reaction? Very simple, very easy. What is the name? Right? I'll give you side here. This is the product. This is the reactant. This is Br2 red phosphorus water. What will be the name of this reaction? What will be the name of this reaction? This is called, I want to see it in the chat box. Yes, this is called HVZ, Helmholtz-Zielinski reaction. Okay? Helmholtz-Zielinski reaction where the alpha carbon, this is carbonyl carbon, the carbon next to it is alpha. If it has a hydrogen, that will be replaced by halogen that you have added. Here you have added Br, so it will be replaced by Br. So that means this is going to be the answer. So first is the correct answer because that is your alpha hydrogen. Okay guys, everybody in the chat box, is that clear? Yes, definitely you have to memorize the colors as well, right? You have to memorize the colors as well. Azodide we will do in amines as well in detail. So we will do azodides in amine chapter. That is your next chapter, right? So definitely you have to remember the colors also. Yeah. Okay, with phenol which color, with aniline which color, right? This was a different reaction, right? Here they have not asked you the color, but maybe this year they can ask you the color because already they have asked you this question, right? But you have to remember for phenol and aniline, right? Okay, and beta naphthenol also, right? Okay. Yes, everybody. So now in the next lecture, we are going to we are going to complete amines in one go only. I'll take up some previous year questions as well for amines. Then we will be left with biomolecules, right? We will do, then after that we'll do biomolecules. After that, we are going to start the revision, right? And I'm going to teach you everything with the help of previous year questions, okay? Because I feel that some of you have already done enough work, right? Some of you have already done a lot of, like, you have been revising that like so many times. So what I feel, I want to cater to both the students who want previous year questions and some good practice questions, and those students who want to revise things. So we will revise with the help of questions, right? Okay. And if you have any other suggestions, you can always write it down in the chat box. I'll be waiting for your comments. I know you guys are very confused when it comes to writing the comments, but do write it, because that's the only way I can understand what you want on this channel for chemistry. Okay. Okay then, bye-bye, take care, see you all in the next class that is happening on Friday, and we are going to complete and finish amines chapter in that lecture. Bye-bye, take care, see you all in the next class, bye-bye.